Okay, so in the previous video we have proven this sine alpha plus beta equals sine alpha cos beta plus cos alpha sine beta. In this video we are going to prove or find out what cos alpha plus beta equal to. Okay, how do we do that? Very similar to the previous example. We consider the same scenario where we have two angles alpha and beta, and I am going to be a bit quicker this time because it's similar. So considering this triangle OAD, which is a right angle triangle, cos alpha plus beta is going to be OD over H, the hypotenuse, base over hypotenuse. So we have to figure out OD. What is OD? OD is OC minus DC. OC minus DC over H, right? So we have to first find out OC, then second find out DC. So how do you find out OC? Consider this triangle OBC. OBC, if we consider OC, so to find out OC we have to use cos alpha. Cos alpha equals base over the hypotenuse. So OC over OB, or OC equals OB cos alpha. Now how do you find out OB? Consider the top triangle. If we write cos beta, what is cos beta? Cos beta is OB over H. OB over H, or OB equals H cos beta. So here OC would be, what is OB? OB is H cos beta. H cos beta cos alpha. One part is done. We have to find out DC now. This guy DC. Note that in this triangle EB is same as DC. So we have to consider the triangle AEB, and this angle is alpha, already known. AEB. So in this triangle AEB, I can write sine of alpha equals EB over AB. EB over AB, or EB equals AB sine alpha. Fine. How do you find out AB? Again, consider the big top triangle. So sine of beta equals AB over H. Combining these two, I can write EB equals AB. AB is from here. AB is H sine beta. Jumping a step. So H sine beta sine alpha. So we have one guy here, the other guy here, and EB is same as DC. EB is same as DC. So I'll just write DC here. Right? So OC and DC. Now we'll substitute here. Cos alpha plus beta will be equal to, H is there, so this H and this H will get cancelled. We'll have OC first. So cos alpha cos beta minus sine alpha sine beta. Let me write it down here. Cos alpha cos beta minus sine alpha sine beta. Now, just as I always say, it's not just about doing something, but also about figuring out in how many ways you can do the same thing. So we'll try a different way. Then at the end you can comment which one you prefer. You know this already. That sine square theta plus cos square theta equals 1. So you can use this identity to find out cos alpha plus beta if we know the expression for sine alpha plus beta. How? Cos square theta equals 1 minus sine square theta. Right? Then we should have cos square alpha plus beta equal to 1 minus sine square alpha plus beta. So sine square alpha plus beta we have to find out. We have sine alpha plus beta is this expression. We have to square this expression. 1 minus, what is the square of this? Two things added. sine square alpha cos square beta minus cos square alpha sine square beta minus 2 sine alpha cos beta cos alpha sine beta, right? Now, I'm going to do a trick. 1. This reminds me of this. Sine square theta plus cos square theta. I'm just going to write sine square beta because I like beta more than alpha. Cos square beta. If you like alpha, you can write alpha. Minus sine square alpha cos square beta minus cos square alpha sine square beta minus 2 sine alpha, and I'm going to keep the sines together. Sine alpha, actually let's keep the cos first and then all the causes together. Cos alpha cos beta sine alpha sine beta. Oh, that's a very bad beta, right? Now from this guy and this guy, if I take sine square beta common, what do we get? Sine square beta. So from here I'll have 1, and from here I'll have minus cos square alpha. Alright? And from this guy and this guy, if I take cos square beta common, I'll have 1 from here minus sine square alpha minus 2 cos alpha cos beta sine alpha sine beta. Right. Now again, what is 1 minus cos square alpha? Using this, the identity. That is sine square alpha. So sine square beta sine square alpha plus this is cos square beta. And what is 1 minus sine square alpha? Cos square alpha minus 2 cos alpha cos beta sine alpha sine beta. Now just to put things comparable to that in that fashion, I'll write this guy sine square alpha sine square beta after this guy. Right. See, this is a minus b whole square formula, where this is like a, this is minus 2ab, and this is b square. So I can write cos alpha cos beta minus sine alpha sine beta whole square. And what is this? This is cos square alpha plus beta. Now get rid of the squares. Get rid of the squares. We have got exactly the same thing as that. Do you prefer this method? I personally prefer the geometric one. Way better. You can see it much better.